Let's talk about a secret weapon that's hiding inside a piece of tech you probably use every single day, the good old hard drive. We're going to get into a feature of its onboard cache that, once you get it, it'll completely change how you think about storage performance.
Oh, we've all been there, right? You're backing up your photo library, maybe moving thousands of little documents, and that progress bar just crawls. It barely moves. You've got a fast computer, a fast network, so what gives? The frustration is real, and I promise you the answer is probably not what you're thinking. So yeah, the answer is the hard drive's cache. But hang on, most people think a bigger cache is just for absorbing a bigger burst of data at the beginning of a file copy. And sure, it does that for like a second or two, but that is not its real superpower. Today, we're gonna bust that myth, because the cache's true job is way smarter and a whole lot more important.
To really understand our hero, the cache, we first have to meet the villain of our story. And the villain here isn't bad software or a slow cable. Nope. It's the cold, hard laws of physics that run a mechanical hard drive. Okay, so think of it like an old-school record player. If you want to jump to a different song, you have to physically lift the needle's arm and move it to a new groove. A hard drive's read/write head is doing that thousands of times a second, and every single one of those little movements, no matter how tiny, costs precious milliseconds. That's seek latency.
And that's not even the whole story. Once the head gets to the right track, it has to wait. It just sits there, waiting for the platter, which is spinning at thousands of RPMs, to bring the exact piece of data around underneath it. It's this constant waiting game, and it adds even more delay to every single operation.
So this leaves you with two basic scenarios. First, you have a sequential workload. Think of one giant video file. This is a dream for a hard drive. The head just goes to one spot and writes in a long, beautiful, uninterrupted line. But then there's the random workload. This is our photo library. It's a complete nightmare. It forces that head to thrash back and forth like crazy, paying that time penalty for seek and rotation over and over and over again. And just how big is this difference? The scale is absolutely mind-blowing. A hard drive can be over 180 times slower when it's dealing with that chaotic random mess compared to just writing one clean sequential file. That's not just a little difference, that is a total performance collapse. And that is the very problem the cache was born to solve. All right, so if physics is the bad guy, how does our hero fight back? Well, this is where the cache comes in. It's a small pool of super fast memory right there on the drive's circuit board, and it has this brilliant two-part strategy to beat that mechanical slowness. So here's the job everybody thinks the cache does. When your computer sends some data over, the drive doesn't write it to the slow spinning platter. No, it zips it right into that fast cache, and then it immediately lies to your computer. It says, yep, all done, got it. This is what creates that super fast burst you see at the beginning of a transfer. The drive then quietly deals with the slow mechanical part later in the background. Now, this little trick, it has a dark side. The data that's sitting in that cache is volatile. That means if the power gets cut for any reason, bam, before the drive has a chance to permanently save it to the platter, it's just gone, forever. Your computer thinks the file was saved, but it actually just vanished into thin air. But you know what? That whole buffering thing is just a sideshow. Here is the real genius of the cache. It's not just a dumb buffer. It's an intelligent staging area. It collects all those chaotic, jumbled commands your computer is shouting at it. But instead of just doing them in the order they showed up, it runs a sorting routine. It's often called an elevator algorithm. It reorders all the jobs based on where they physically are on the platter, creating the most efficient path possible. It's just like an elevator picking up people floor by floor, in order, instead of just zipping randomly up and down the building. So what this all really means is that the cache's #1 job is to use a tiny bit of fast memory to buy itself enough time to outsmart its own physical body. It takes a total mess of random commands and completely transforms it into a smooth, efficient, almost sequential operation that the mechanical parts can actually handle without breaking a sweat. Okay, that's the theory. Now that we know this secret, let's bring it back to the real world. Why does a specialized NAS drive handle these tough jobs so much better than a standard desktop drive? Well, the answer is all about how they're built to use that cache. Let's look at the specs side by side. You can see the big differences right away. The NAS drive spins faster. That helps reduce that rotational latency we talked about. But look at the cache. It's way bigger. In this case, 4 times bigger. And maybe most importantly, It has special firmware that's designed to run that elevator algorithm way more aggressively and efficiently, because it knows it has to do it 24/7.
And this is so important to get. 4 times the cache does not mean 4 times the performance. The benefit is nonlinear. In other words, it gets exponentially better. But why is that? Think about it like this. The cache is basically giving that elevator algorithm a set of problems to solve. A smaller 128 megabyte cache gives it a pretty small window of incoming commands to look at and reorder. But a 512 megabyte cache, that gives it a window that's 4 times larger. And with that much more data to analyze at any given moment, the odds of finding efficient paths and finding little adjacent files it can merge, well, those odds go through the roof. It can just make much smarter decisions.
And here is what really makes copying photos the ultimate torture test. For every single photo you copy, the drive doesn't just write the photo. Oh no, it has to perform a bunch of other tiny, separate writes for all the background file system stuff, things like timestamps, file locations, and journal entries. It's this hidden write tax, and it forces the drive head to just thrash back and forth between the part of the disk with your photos and the part with all this metadata, creating the worst random workload imaginable. All right, let's put it all together. What does all this techie stuff actually mean for that photo backup that's been running for 3 days? The results are pretty staggering. So after that initial burst of speed from the cache is all used up, the performance settles into its real sustained average. That standard desktop drive, it's totally overwhelmed by the random I/O, and it might chug along at a painful 8 megabytes per second. But the NAS drive, with its bigger cache and smarter firmware constantly reordering that chaos, it can hold a steady average of around 35 megabytes per second.
And to put that into perspective, let's say you're trying to copy a 4 terabyte photo library. With that desktop drive, you'd be looking at an estimated 138 hours. That is almost 6 full days of just waiting.
Now the NAS drive, look, it's still a big job, but it would finish in about 32 hours, a little over a day. The difference is that you are literally saving days of your life.
So there you have it, the final score. The right tool for the job is over 4 times faster. We're not talking about a minor upgrade here. This is a fundamental change in what the hardware can do, all thanks to that smarter, bigger cache system. So let's just quickly recap the big takeaways. First and most important, a cache's main job is smart reordering, not just bursting. Second, copying lots of small files is a hard drive's absolute worst nightmare. Third, NAS drives are engineered as a whole system, cache, firmware, and mechanics, to specifically win this fight. And finally, and this is crucial, remember this all depends on the workload. If all you do is copy huge video files, this massive performance gap almost completely disappears. And all of this really leaves us with one last question for you. Now that you know about the hard drive's secret weapon, take a hard look at your own setup. Are you using a screwdriver to hammer in a nail? Because understanding your workload, that's the real key to choosing the right tool for the job.